We are building non-invasive hormone health monitoring for women. We are measuring hormones for women like LH, FH, progesterone, estrogen, which are very crucial for women that are trying to conceive. Over 50% of ACL injuries happen due to not being able to cycle sync. Only 13% women have a regular cycle of like 28 days.
Abhinav Agarwal is a Stanford-trained AI scientist redefining healthcare. The mind behind Chaos AI's Argus, the world's breakthrough non-invasive glucose monitoring wearable.
Research shape how you think about building AI that humans have to trust.
For someone who is perimenopausal or in menopause, like every month, like the app would send a notification that, hey, your period seems to be delayed. Maybe you should go talk to a doctor. But the user already knows that they are menopausal, so their period's supposed to be delayed, and the app is just not learning from them.
You've built ML systems across banking, dating apps, and medical devices. Is there a universal principle that applies to all of them?
Building in this AI space, every single day, like you age by one day, but these systems and the knowledge that is produced in this field, like it's growing by like 2 or 3x. So it's super crucial to kind of keep yourself like fully updated on that.
Welcome to Automate or Die Trying. I'm your host, Will Ramos. Today, we're joined with Abhinav Agarwal, founder of a stealth startup and AI researcher at Stanford Center of AI in Medicine and Imaging, and former CTO at KOS, where he built Argus, the first truly non-invasive continuous glucose monitor. Abhinav's been shipping AI in healthcare, fintech, and consumer tech since before most people could spell transformer. He's built ML systems at Carthai Bank, worked in vision perception research at Stanford, and somehow found time to co-found and exit Silk AI, all before finishing his master's. Today, we're going deep on what it takes to build an AI system with systems that touch human health. Where moving fast isn't an option, but neither is getting it wrong. Abhinav, welcome to the show. Glad you're here.
Thanks, Will. Thank you so much for the kind introduction, and thanks for having me.
Sure. So for listeners, that are listening, what are you building right now, and what scale and stakes are you operating at?
Yeah, so I'm building Clear Health. We are building non-invasive hormone health monitoring for women,
Okay.
and also a holistic world model for biology for women. Because one of the issues that I saw working in the space was that women's health was pretty much neglected, and also wanted to build this system out because also healthcare or digital health moves very slowly with all the regulations. And then there were a lot of noise around some companies like, with their end-to-end encryption, like related issues, and with, um, you know, analytics SDKs that they had that would lead to users like protected health information getting leaked. So we wanted to change all that and build out a tool or a service that women and users in general can actually trust, where they can take ownership of their health, can take ownership of their data, and sort of democratize that space.
Okay, so what does non-invasive actually mean technically? When that term?
So when you think about like any invasive, any blood tests, for instance, so whenever you're breaking the skin, that's invasive.
Okay.
Be it actual blood tests, be it microneedles like in your CGMs and all that. So even microneedles, like they break your skin's dermis, right?
Okay.
That's invasive. And other aspect of that, you could argue that when you measure something from urine samples and all that, that is non-invasive, but those are like biofluid based solutions. So what we are building is a non-invasive solution where there's no breaking of skin. It's a wearable device that has a host of sensors and like edge deployed ML, which is able to measure all the biomarkers that we want to measure. We track over 100 biomarkers actually using our device, using the Claire device, and to non-invasively measure the hormonal health of women.
Okay. So give me an example, like what kind of test would that cover, like a non-invasive test?
So normally you can take the example of, so for instance, at Coase, I'll start from there.
Hmm.
we built Argus, which is a non-invasive blood glucose monitor.
Okay.
So current blood glucose monitoring solutions either is a blood test, which is a needle that you write and then do that plasma based test and all that. Other option is you have a CGM like Abbott's or like, Stello or something, which has micro needles in it, which is again like you wear on your arm and then it's continuously measuring your blood glucose levels. But what we did there was we built a sensor suite, like a wristband, which doesn't need any, uh, micro needle or any like breaking the skin. It
Okay.
just is able to optically measure the blood glucose levels by, employing like, a host of you know, deep learning models and all that, along
Oh,
with like signal processing. So that's where goes like the Argus. That's how Argus works. But what we are doing here at Claire is we are measuring hormones for women like LH, FH, progesterone, estrogen, which are very crucial for women that are trying to conceive. And also when women hit perimenopause or menopausal age, for them to be able to truly like cycle sync for athletes and to train because uh over from our research like over 15% of ACL injuries they actually happen due to not being able to cycle sync due to overtraining around like periods of cycle when you're not supposed to like train like in a certain way. So it's super crucial for the athletes as well to be able to cycle sync and monitor their hormones. So that's what uh, it sort of changes being able to measure that data continuously and non-invasively. Because for women or couples that are trying to conceive, they have to take a basal body temperature every morning. They have to go through blood tests every day at least, like and usually between days 9 and 14, they have to go through blood tests every single day. And they have to go through multiple cycles of that of IVF to be able to, get successful outcome because there's a lot of guesswork involved. And then the current like period tracking apps and all that, they don't necessarily take into account like personal biology
mm-hmm.
of the user. They are based on more like generalized population based statistics, which doesn't or necessarily apply to a particular user. Like only 13% women have a regular cycle of like 28 days. Um, and then of these app users, like over 50% feel that their cycle came early than what the app predicted, and 72% women feel their cycle came late than what the app predicted. So
Wow.
that's what issues that sort of exist in this space.
Wow, that's fascinating. So you've been building AI since you were a teenager, right? So research at New York Academy of Sciences, internships at DE Shaw, Stanford GBS. So, but healthcare AI is a different beast, right? So, what pulled you into building systems where the cost of being wrong could be someone's health?
So that's exactly why like I am building these systems
Hmm.
because one of the issues with healthcare right now is there's so much like administrative overhead and there's like
Yeah.
the system without sounding like too cynical, like it's in a way broken where to you have to like wait super long to even get basic tests done and all
Hmm.
that. And there's so and then of course like any AI tools that come along in healthcare, they won't be replacing the medical professionals or like doctors or any of that. They would assist them. They would actually allow users to take better control of their data.
Hmm.
And I was just reading this research actually. It just got published I think a few days ago where they did this research with medical professionals who used uh, actually mostly on dermatologists who use these AI tools
Right.
to you know kind of assist them in making the diagnosis, and their accuracy of diagnosis like it actually improved greatly when they were assisted by those tools versus when they were not. Of course the system wasn't perfect. There were a lot of other uh things that could have been improved there, but what we are seeing the trend is like if you build these tools out responsibly, if you use these tools responsibly, then there's a lot of value add here. And uh, and that's what we are, setting out to do.
Yes. Well, now, was there like a specific moment or project that made you change how you think about risk in AI systems?
So I would say like my journey in the AI in healthcare started when I worked on Apple's pediatric Apple Watch study, which was for arrhythmia detection in children using Apple Watch.
Mm.
While working on that, like realized the kind of impact that AI can have, and also when you're doing like when I was doing research on the CGM space when I was building Argus, so stakes there were pretty high because if someone's hypoglycemic, or someone has like type 1 diabetes and like you don't predict well enough in time that their sugar levels going down,
Yeah.
and or going up, or like they don't get the intervention if someone's using insulin pumps or any of that, then the stakes are pretty high.
Mm.
So that was something where we had to think a lot about, both from the regulatory perspective but also from what would make this a safe device to use for the user, where uh, they understand the risks. Of course, with any system, there are flaws in the system, but like it's really important that you understand the risk as a maker, and you can communicate that well to the user so that they're well aware of what's the best way to use a certain technology or a certain piece of device. And I took those learnings, and as we are building Clear Health, like we have been very focused, like since day one.
Mhm.
We are like a regulatory affairs officer who spent years at FDA reviewing medical devices. We involve like QMS, like a quality management system, since day one, so that anything that we build, from any piece of software to any piece of hardware,
Mhm.
it's all uh, made or built with keeping that user safety and user experience in mind.
Mhm. Okay. Now, at Stanford's Vision and Perception Lab, you were modeling how the brain actually sees, right? How did that research shape how you think about building AI that humans have to trust?
So all of these experiences, they kind of like built upon each other, where um I was on the technology on that side, like I was getting more and more fascinated and excited by what all we can see just non-invasively. Like there's so much data in there, and if we just figure out how to make sense of all that data that our body holds, like it's very fascinating. It's very fascinating the kind of things you can do with our biology, kind of interventions you can make, the goals that you can achieve. So that experience, like being able to see like how images are getting formed in a visual cortex, like how we are processing all of that, and being able to measure that
Mhm.
just non-invasively without even like a truly you know any like MRI or anything, that was just super fascinating for me to work on. And that the signal processing approaches I had kind of sort of employed there or like learned there, that also contributed to me building Argus or working on Claire.
Okay. So yeah, let's talk a little bit about Argus, right? That was you built like the first truly non-invasive continuous glucose monitoring. So for our listeners who aren't in that, health tech space, what makes non-invasive so hard and what did you actually have to solve to make that work?
So one thing is blood glucose molecules, like they're very small in size.
Mm-hmm.
So the optical properties, like it's when you are blasting it with like your skin with like visible ranges of light or even infrared ranges, like they're not directly optically reacting to that. So what that means is, like, in the optical signal that you get back from a sensor, it's like of that only 0.01% may have like some information about your blood glucose levels. So which makes it a super super hard thing to sort of achieve um non-invasively. um and to solve for that, like you need to, and if you were to deploy like some traditional like signal processing and the ML approaches, what ends up happening is like you discard uh that data for uh blood glucose levels as noise. So you don't even account for that data as signal. So signal to noise ratio is practically zero there.
Hmm.
So that's something you have to really solve for in building these AI systems that can take this multimodal data coming in from all the sensors and truly like uh extract that, like, kind of like a needle in a haystack sort of issue, that buried signal for a biomarker that you want to track. And now with all the deep learning methodologies that we have, plus the ability to build these models that are not just predicting based on uh the some time series data, but are actually able to understand the interactions between different biomarkers, different interventions,
Mm.
between different physiological changes that are happening throughout your body. That is actually super crucial to be able to measure the things that we weren't able to measure before from these sensors.
So what did the machine learning architecture look like? Were you doing like signal processing, computer vision, or was it something entirely different?
It's actually a mix of both. So it was very like actually very integrated and ensemble model, which
Okay.
was doing, of course, on the signal processing side, we're extracting around 547 features from the raw data that was coming in from the sensors. And then, and one thing you would normally hear in, ML or the AI and deep learning space is like, you normally want to like downsize the features. You don't want to use too many features because that
Right.
distracts these models.
Yep.
So being able to uh, have those features figure out like to be able to do that feature engineering from there. And then these models were actually a host of models from computer vision to the models that are like truly like understanding that multimodal stream of data that's coming in.
Mm-hmm.
So you would, I mean, you would see like these models were all baked into the architecture, like all the traditional approaches you would see like CNNs and all of that, they were pretty baked into the architecture, but they were combined with some proprietary architectures that we had developed in-house for that as well.
Okay. So it looks like, based on my research, it looks like you exited Argus in October 2025, correct? Around that time. So what did done look like? I mean, and was there anything you would have done differently?
No, it was a very great like learning experience for me, and I'm under NDA, so can't say too much. But my previous company was they are going through a FDA approval process right now. They are more focused on big pharma and all that.
Mm-hmm.
I built a consumer device, so I left that to build Claire to
Right.
be like consumer device. Yeah.
So let's talk about trust and specifically in healthcare, right? Clinicians don't trust black boxes, patients don't trust algorithms with their healthcare. How do you think about building an AI system that humans will actually use in high stake decisions?
So that's where actually explainability in AI comes into play.
Mm-hmm.
So what you've seen with like a lot of AI systems in healthcare that currently exist, like they don't have any model to be able to explain like why they gave the kind of prediction it gave. For instance, like if you look at some of the period tracking apps even, which are algorithmic or some even use machine learning models, right? So they tell you like this is the date you will get your period on. Uh, Now, as a user, if you get it on that day, it's good. If you don't get it on that day, you would think there's something wrong with you
Hmm.
or your body. But because you don't know why it gave the kind of prediction it gave. It could be either just averaging it out, totally guessing. You have no idea what's going
Right.
on there. So, what we are focusing on is building that explainable AI, like building that explainability in the AI, which is truly explaining like why it's making the predictions it's making. For instance, it could be something like, hey, uh this week we noticed like your sleep quality has been down by 20%, like you have been sleeping getting less sleep, and from the past what we have seen, like when you sleep less your period does get delayed by a day or two. So most likely this week, like your period was supposed to arrive on, let's say, Gen 6, but it's likely going to arrive on Gen 8. Now that kind of reasoning like builds that trust where you feel like you are uh like it's truly like it's personalizing to you, it's understanding like your physiology, your behavior, your actions, instead of just giving you some predictions based on some generalized population metrics. So that is one of the ways to build trust. Second, to allow the users to tell the AI when it's wrong and the AI actually listening and like making those changes. For instance, one of the things we found talking to our users and talking to like, early, user research is that even when like for someone who is perimenopausal or in menopause, like every month, like the app would send them notification that, hey, your period seems to be delayed. Like maybe you should go talk to a doctor. But the user already knows that they are menopausal, so their period's supposed to be delayed, and the app is just not learning from them. It's like kind of just very, it's almost like a static app in a dynamic world, which
Mm.
doesn't work.
Yeah.
What you need is dynamic app and dynamic AI solution that evolves with you throughout your life cycle. So that is something that's missing, and that also kind of erodes trust. Like even if an AI system you built may be great and exceptional at the very beginning when the user starts using it, but over a period of like weeks or months, it would erode. The quality would erode because if it does not evolve with the user. So that is truly important to build that trust. First, like the transparency,
Yeah.
explainability, and that evolution with the user.
Now, what is your framework for deciding what should be automated versus what needs a human in the loop whenever these decisions are being made?
Yeah. So AI is good at making prediction. Like one thing AI is good at is like being able to digest and synthesize tons of data. So for instance, when you're looking at a user's data, for instance, and they may have electronic health records from 3 years.
Mm-hmm.
They may have wearable data that they are collecting from several months or years. And that is like a huge amount of data, which for a human to practically review in a matter of a few seconds or minutes is sort of impossible. But so AI is good at that, being able to digest that much amount of data under the constitutional guidelines that you give it, and being able to, uh, you know, kind of give you a TLDR version or kind of able to make predictions based off of that. So those are the tasks that we choose to automate versus the tasks, for instance, when the AI does make predictions and insights, then it's of course reviewed by a human expert in the loop, where it's be it a medical professional for a medical insight or be someone else. So that at the end of the day, like when you're building in like consumer health or even health AI, like this space, user trust is super important, and they need to know that whatever insights they get, potentially they could be that it's not always correct, because it's same thing, right? When you go to ER or urgent care, sometimes you get a misdiagnosis. You
Mm-hmm.
go for like a stomach ache, your doctor probably gives you like pain medication for a day or two, and if it doesn't get resolved, then they would probably go to see like whether you may have appendicitis or something. They won't directly just like do a test for appendicitis, right?
Mm-hmm.
So so that's something user should have that understanding that, like, hey, like this is even with the human or medical expert in the loop, those predictions won't be like 100% like right the first time around. But what that builds is like, because users know like, hey, this is like, if they have that explainability in the system plus like a human reviewer, that builds that trust that that it's not some dark box system versus their predictions are based on a certain, even though it's an AI system, but it's still coming from some sort of logical deduction, which if a doctor or a diagnostician were to review it, they would agree with it that the process makes sense. So that it is super important to kind of have that process oriented system actually.
Okay. What's a mistake that you made early in your career that you never repeat?
I would say probably like not starting out early on in the AI in healthcare space, because I
Mm.
feel like this is something I've been really enjoying
Mm-hmm.
in over the past like couple of years that I've been working in this space. So I actually, before I got into AI in healthcare space, I worked in AI in finance, I worked in AI in education, I worked in like three or four other spaces before I truly found something that I feel passionate about, which is AI in healthcare. So probably I would have started out with, if I had that hindsight, then I would have probably just started out with AI in healthcare.
Yeah, so that kind of leads me to my next question. You've built ML systems across banking, dating apps, and medical devices. Is there a universal principle that applies to all of them?
I think one is, first of all, like there needs to be that understanding amongst like be it the builders or the users that AI is not some like magical god that would just fix everything.
Mm-hmm.
Like it would amplify whatever values that let's say your organization holds. For instance, like it would not like magically come and change something. So that is super important. It could like make certain process faster. It could make certain process slower. So there needs to be one principle is being very intentional about how you use these tools that are available to you and like in what and also being intentional about like how they would impact, be it like if it's something you're deploying to the users, how it would impact their experience. If it's something you're building for your internal team, how it would impact them. So for instance, one thing we did is so QMS systems for every healthcare company or like medical device company, anything, they all have to have a quality management system. But those systems, they haven't changed in decades. Like if you open like some of the incumbent systems, like they look like they're still living in 2000s.
Mm-hmm.
So what we did at Claire is we built out our own internal QMS system, a very automated AI powered system that saves a lot of time for our engineers, for our team,
Mm-hmm.
but also uh, s- like build with the needs of like our organization in mind. So those are the kind of things you can truly automate, like things that are time sync for your team, which does not truly like interface with the end users. So, and then, but when you build like an AI tool that build interfaces with the end user, for instance, like a dating app or like this healthcare app or any of those things, so that's when you have to be actually even more intentional about how you deploy these things because people would always use these tools in a way different than what you have intended or what you have thought of. So it's super important that you always like launch these with like a controlled beta or alpha where you can see like how the users in the real world are going to be using them. Otherwise, like you would set yourself up for a disaster because you would think of 10 things which you build evaluation systems for or you like build these tools out for, but the moment you release it in the public, people would start like using it in a way which you didn't think of, and then that would like wreak havoc like in terms of like a lot of unintended consequences in terms of like the kind of things they may unlock with that. For instance, when like Grok released like their image generation model on X, like suddenly like people started generating like non-consensual like imagery using that, right? Because they hadn't really like thought out like in what way people would use it. So that's super crucial like across industries is to think through the life cycle of a product and the experience it would have for the user and the way they would use it.
So I saw you publish worked on structured pruning of Llama 3.1 for edge devices. Talk to me about that. What's the trade-off between model capability and deployment constraints in healthcare?
Yeah. So one of the things that I'm a big proponent of in healthcare is that people are very protective of their data, as they should be. And the health data, like, I mean, no one like truly feels comfortable knowing that a company's AI system is sending their data via API to some external third-party provider,
Mm-hmm.
uh, which may do whatever they may want to do with that data, like whether they want to train their models further, whether they want to do something, but that is definitely an issue. And now with all the recent advancements they've been seeing in the RL training, in the reasoning model capabilities and all that, the open source models, the smaller models, they are becoming very capable for specialized tasks. Of course, like a smaller, like, a 2, 3 billion parameter model is not going to be like, as smart as like a trillion parameter model in every single task. But if it's specialized to a particular use case, then it can be just as smart. Uh, because for like a you can think of it this way, like a trillion parameter model is also doing it's also been trained on hundreds of domains, hundreds of tasks. So it's not like all chain parameters are like being used for a particular domain, right? So if you have the smaller model, so that's one of the trade-off where if your need is a specialized domain, then it's actually easier to align a smaller model rather than a large model which knows everything about like the entire world basically. One of the issues though with deploying on the edge is the token throughput, because that's where the user experience comes into play. Like if you're deploying an edge model on a user's phone, and if it's just producing like, if it has to reason, then it has to produce thousands of tokens just for its reasoning.
Right.
And the user response that it has to give like also has to have maybe like around 50 to 100 tokens or something. And if the token throughput is super slow, then the user experience is totally broken no matter how good the response actually is. So that's one of the trade-offs which you have to kind of look at, and that's where the pruning came into play, where of course, like there's some strategies for quantizing the models and all of that. Of course, you would do that. But with pruning, like you actually make the alignment easier because you are removing the parameters that were not contributing much to the task that you want your model to perform. And you are also, while maintaining the structure of the model, like so for instance, like for a Llama 3118B, like you don't mess with that group query attention head sort of architecture that it has while reducing the parameters. So you maintain that architecture of like what makes that model, like what gives that model the strength that it has, but you also like trim it down and like, make it, it's almost like, sending a model on a dieting program where
Right.
like it just instead just losing weight indiscriminately, it is just restructuring the fat, where restructuring the body, where reducing the fat in gaining the muscle mass and all that. So that's basically what you do when you do a structured pruning of the model, and it improves both the throughput of the token, so makes the model faster. Does have definitely some trade-offs for the accuracy, but that's something where you have to see like how much you want to prune, and you of course like build those evaluation systems around your task where like this is my tolerance for like reduction in accuracy for this much gain in performance. So those are of course like subjective case by case things that you have to take care of.
Yeah, that was kind of my next question. How do you validate that those prune models still perform safely in a medical context, right? So you're saying accuracy is a trade-off for that?
Yeah, I mean, of course, like different things would have, I mean, for certain use cases, like, a precision recall curve might make more sense and accuracy. And certain things are not that straightforward as like a binary classification or any like multi-classification thing, like if it's more of a regression problem. And then certain problems may not have a straightforward scoring mechanism. For instance, these metrics, they were made keeping in mind, like when you have sort of a very like, you know, definitive solution, because then you can very easily like measure these metrics or the performance. But when it comes to these LLM, a lot of the kind of questions and the things that they deal with are not as straightforward or have a definitive like right or wrong answer.
Mm.
So they sort of like operate that, you would say, I don't think gray zone is the best definition, but they operate in that like a little bit of uncertain zone. So for that, like building out like an evaluation system, uh, that can truly like do the reward optimization well in terms of or like designing a good objective function for these models to be able to also evaluate them on your test set. That is super crucial. So accuracy is like, I think it's a very like crude term that we can use, throw around, but of course like you would choose like different metric based on your particular use case.
So Abhinav, man, you've built and exited companies, published research, worked across 3 continents. If you had to distill it down, what's one principle or lesson you'd pass on to other builders working at the intersection of AI and high stake systems?
I would say one, like definitely have like the primary axioms that drive you like at the forefront of what you do. For instance, like for me, one of the things is like making sure like whatever I'm building like is going to be impactful. So that is one thing. In that sense that like I'm super like excited about AI in education and AI in healthcare, because those are the two fields where I believe like uh they have been super administrative fields, and now with AI, like we can make those two things accessible to a large, like to the people who historically haven't gotten like access to. So that's something. So know what your axiom is, like it may be something else for you, and keeping that at the forefront so that you are always like honest to yourself. Second is always be curious, especially when you're building with AI and like building in this AI space. Every single day, like it seems like you age by one day, but these systems and the knowledge that is produced in this field, like it's growing by like 2 or 3x, 3x of that. So it's super crucial to kind of keep yourself like fully updated on that. Like instead of, waiting around for someone to drop a tutorial or for someone to like, tell you what to do or what to learn, like you really need to be plugged in and be immersed into the field, uh, like what's happening and to be able to like, be, like deploy these things.
Now, is there something right now that you're exploring or learning that has nothing to do with your day job?
Well, I'm learning tango. Did tango like for a few years at Stanford, but
Nice.
continuously learning because tango is like, unless you are doing it for 10 to 15 years, you are still a beginner.
Yeah, absolutely. Absolutely. Now, Abhinav, thanks for coming on. This was a masterclass in building AI where the stakes are real and the margins for error are zero. So, to everybody listening, thanks for joining us on Automate or Die Trying, where the future is being built in real time. If this conversation helped you think differently about speed, security, or shipping AI that matters, share it with someone that builds. I'm Will Ramos. See you next time. Thank you.
Thanks, Phil.